The solar activity and the sun just ripped off a comet's tail. We have a geomagnetic storm watch and a CME coming, probably giving us a glancing blow to Earth. The latest on space weather. Geomagnetic storm watch G1, Earth's magnetic field is reverberating from a CME strike yesterday, which sparked a short-lived G2 class geomagnetic storm. Another CME is on the way, as NOAA says, forecasting, and it could be delivered by Glansing glow tomorrow, May 19. Major G1 class storms are possible when the next CME arrives. The sun just ripped off a comet's tail. The Earth is not the only celestial body experiencing the extreme space weather from our sun. Comet 12P Pons-Brooks just got hit as well. The effects of a CME strike are shown in the May 15 photo taken by Ujvárosi Beáta using a remote-controlled telescope in Hakos, Namibia, of all places. And this is what you can see. The tail got ripped off. This is a photo taken from Namibia. And note the structure near the comet's nucleus, the inset. This is called a disconnection event. It's caused by a CME, or fast solar wind stream, hitting the comet. One of the earliest recorded examples of this phenomenon occurred in April 2007, when NASA's Stereo A spacecraft watched a CME strike comet and to rip off its tail completely. Current images of 12P comet clearly show the effects of stormy space weather conditions and its tail ripped off by solar wind, says Beáta. And we have a strong solar flare, the new sunspot AR 3685. That's around the west part of the sun, as we can see right here. 3685 erupted yesterday, May 17, at 2108 UT, producing a strong M7 class solar flare. What's an M7 class solar flare? Classification of X-ray solar flares. A solar flare is an explosion of the sun that happens when energy stored in twisted magnetic fields, usually above the sunspots, is suddenly released. Flares produce a burst of radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. Scientists classify solar flares according to their X-ray brightness in the wavelength range 1 to 8 angstroms. And there are three categories. X-class flares are the biggest. They're the major events that can trigger planet-wide radio blackouts and long-lasting radiation storms. M-class flares are medium-sized. They can cause brief radio blackouts that affect Earth's polar regions. Minor radiation storms sometimes follow an M-class flare. Compared to X and M-class events, C-class flares are small, with few noticeable consequences here on Earth. The strong solar flare, this new sunspot, produced the M-class flare. NASA Solar Dynamics Observatory photographed, of course, its explosion. This is what we see here. This follows the X flare from the same sunspot, May 15. Neither of these flares was squarely Earth-directed, thank goodness, because of the sunspot's location near the sun's southeast limb. The geometry is changing, though. Next week, eruptions from AR 3685 will target our planet. So we'll see what happens in a few days. We have today 2,349 potential hazardous asteroids coming at us, and none of them are dangerous. So now the cosmic rays in the atmosphere. Space weather balloon data, almost once a week, space weather, and the students of Earth to Sky Calculus fly space weather balloons to the stratosphere over California. These balloons are equipped with sensors that detect the secondary cosmic rays, a form of radiation from space that can penetrate all the way down to Earth's surface. Our monitoring program, they said, has been underway without interruption for 7 years, resulting in a unique data set of in situ atmospheric measurements. And the latest results, atmospheric radiation is decreasing in 2022. Our latest measurements, July 2022, registered a 6-year low. When the solar cycle 25 begins, 15% less stratospheric radiation. So what's going on? Ironically, the radiation drop is caused by increasing solar activity. Solar cycle 25 has roared to life faster than forecasters expected. The sun strengthening and increasing tangled magnetic field repels cosmic rays from deep space. In addition, solar coronal mass ejections, the CMEs, sweep aside cosmic rays, causing sharp reductions called four-bush decreases. The two effects blend together to bring daily radiation levels down. And who cares? Cosmic rays are a surprising down-to-earth form of space weather. They can alter the chemistry of the atmosphere, triggering lightning, and penetrate commercial airplanes even. And according to a study from Harvard, T.H. Chan School of Public Health, crews of aircraft have higher rates of cancer than the general population. The researchers listed cosmic rays, irregular sleep habits, and chemical contaminants as leading risk factors. A number of controversial studies go even further, linking cosmic rays with cardiac arrhythmias and sudden cardiac death. Can you imagine? And this is on Space Weather today. What's happening? Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.